Hello friends, greetings. Today we are going to learn about measuring volumes. Before going to that, we need to learn some basic glasswares. A beaker is one of the glassware. Beakers are flat-bottomed, cylindrically shaped vessels with gradation marks on the side. Beakers are not meant to be used for accurate volume measurements. They are often used as a vessels for transferring and mixing solutions. Beakers normally we use in the laboratory. These are all not for accurate measurements. These are all just transferring the solutions, preparing transferring or mixing the solutions. For that it will be used. Okay, not for the accurate measurements. Conical flasks. Conical flasks or Erlenmeyer flasks have a flat bottom with a cone-shaped body and a short neck. You can see here, it's a cone-shaped body, okay, and a flat neck. It's a flat bottom also. It's a short neck. This is a short neck. They have gradation marks. They have see these are the gradation marks. These are all the gradation marks on the side of the vessels. Much like a beaker, it is much like a beaker, and are also not meant to be used for accurate value measurements. This is also not meant for accurate value measurements. These are useful for the titrations. During titration, so we need to rotate the flask. So that is why while titrating, we need to rotate the flask. So it's a cone-shaped flask, so that the solution will be mixed homogeneously. So for that purpose only, this conical flasks are we are using in the laboratory. Next, measuring cylinder. Measuring cylinder, I think you are not seeing the full picture. I'm just decreasing. Okay. This is the measuring cylinder. See, this is the measuring cylinder. Measuring cylinders are also known as radiated cylinders or cylindrical glass tubes, which are closed at one end and fitted with a support to allow the cylinder to be freestanding. So this is a glass cylinder which is closed at one end. See, this side is closed one end, and there is a basement like this, so that it can freely stand on the floor. So, and one side is open. The cylinder has gradations along the length of the tube. So these are the gradations along the length of the tube, and the open end is fitted. End is fitted. This one is fitted with a pouring spout or a ground glass joint. This is a pouring spout. See, here a pouring spout is there, so that we can pour the solutions easily. That is the purpose. Measuring cylinders are okay. Measuring cylinders are not accurate enough for quantitative work. These are also not for quantitative work, but they are useful for approximate volumes. They are useful for approximate volumes. Like if you want 50 ml, it will give approximate. This is not accurate value. You will not get measuring cylinders. Measuring cylinders also you will not get accurate volumes. Keep it in mind. Then next, burettes. So burettes are long cylindrical glass tubes of uniform bore, marked with gradations and terminating at one end with a stopcock tap, which is usually made out of polytetrafluoroethylene. See, burette is a cylindrical glass tube. So even bore. This bore is nothing but internal diameter. This is a even internal diameter throughout the cylinder, and it has its gradations in the glass, and there is a stopcock at the end. so that it can stop the solution, and we can open it also. And this is made up of polytetrafluoroethylene. Its burettes are mainly used for dispensing variable and accurately measurable volumes of liquid. So burettes are useful for accurate measurements of the volumes. We can get accurate volumes here in burettes. Burettes are mainly used for dispensing variable and accurate measurable volumes of liquid. For example, in a titration procedure, see, if you want to titrate, you want the volume accurately, so that we use uh, this burettes, so that you will know exactly what is the amount needed for the titration. Next, glass graduated pipettes. Pipettes of this type consists of a long glass tube with no central bulb. See, some pipettes are having central bulbs. This is no central bulb. This is a even type glass pipette. And this tube is marked with a series of gradations, enabling a range of volumes to be delivered. See here, gradations, a series of gradations, 1 ml, 2 ml, 3 ml, 4 ml, like. And if whichever amount you want, you can transfer. These pipettes are not as accurate as bulb pipettes. These are all for accurate volume measurements only, but this pipette is not accurate than bulb pipettes, and are mainly used for dispensing predetermined volumes where the highest level of accuracy is not required. Here, see, this can be used when can be this glass graduated pipette can be used, means if there is level of accuracy is not that much required. If there is not much required of level of accuracy, then we can use. But if you want accurate volume measurements, this can't be used. Bulb pipettes, glass bulb pipette. These pipettes consist of a long glass tube with a central cylindrical bulb. This is a bulb. A single calibration mark is attached. A single calibration mark, see, you can find here, single calibration mark is attached around the upper end of the tube, and the lower end of the tube is drawn into a fine tip, and finally there's a fine tip will be there. These pipettes are also referred to as transfer pipettes and one mark pipettes. A known fixed volume of liquid delivered through the tip under certain specified conditions after the pipette has been filled to the calibration mark. So this calibration mark, if you want accurate volume measurements, suppose this is 1 ml, you can take 1 ml and you can deliver it accurately up to this calibration mark. Automatic pipettes. See, automatic pipettes are two different type of mechanisms actually. Here you can find only one type of pipette. There is another type of pipette also. You can see now itself. I will just open it. I didn't put the picture here. Few positive displacement pipettes. Positive displacement pipettes model, you can see. Sorry, positive displacement pipette. So, this is positive displacement pipette. Okay, let me explain first. Then I will show the pictures. So there are two different mechanisms are used in automatic pipettes for sorry uh, for aspirating and dispensing liquids. In an air displacement automatic pipettes, the air displacement you are seeing here, no, this one. This one is air displacement automatic pipette. This is air displacement automatic pipette. This type of pipette uses a piston to create a suction to draw liquid into the pipette tip. Okay, whereas positive displacement pipettes have a disposable piston which sits inside the pipette tip and is in contact with the liquid. Unlike air displacement pipettes, there are no air cushion between the sample and the piston. So the aspiration force is unaffected by the physical properties of the liquid, such as viscosity. So positive displacement pipettes are therefore recommended when handling viscous, dense or volatile liquids. So this pipette is air displacement pipette. So this we cannot use for suppose volatile liquids or viscous liquids or dense liquids. In such cases, we can use positive displacement pipettes, which have a disposable piston which sits inside the pipette tip and is in contact with the liquid. We'll see the picture now. So better picture you can get. Yes. It's not coming. Okay. This is air displacement pipette. This one. See, if you see that here, this is a picture. I think you can see the picture. It is not coming out. Bigger one. Yeah. Okay. This is positive displacement pipette. See, the end is different. Okay. The piston itself there is no piston, and actually what it is, disposable piston which sits inside the pipette tip and is in contact with the liquid. Okay. Right. One second. Where I am? Oh, I lost. Yes. Yes, right. I mean, so there are two types of pipettes. What is the takeaway point? There are two types of automatic pipettes. One is air displacement pipette, and the second one is positive displacement pipette. If the liquid is viscous or volatile or dense, you should not use the air displacement automatic pipettes. You should use only positive displacement pipettes. This is the takeaway point from this slide. Next, volumetric flasks. Volumetric flasks, also known as graduated flasks. These are flat-bottomed, pear-shaped glass vessels with a long, narrow neck. See, this is the long, narrow neck. And here you can see a calibration mark here. The neck of the flask has a single attached calibration mark. The top of the neck has a ground glass socket for a stopper, which may be made from polyethylene, polypropylene or glass. Okay, this is a glass socket stopper. This is a stopper. This can be glass or polyethylene or polypropylene thing. Okay. The main use of volumetric flask is in the preparation of a solution of known concentrations. If you want to prepare a known concentration, ppm parts per million, or any concentration, if you want to prepare 1 mg per ml or 2 mg per ml, you have to prepare in this volumetric flasks only. Okay, you should not take 1 ml and add 1 mg. It will not be 1 mg per ml. You have to prepare in the volumetric flasks only. Keep it in mind. It's very important. Okay, now. Actually, we see markings on equipment used for volumetric measurements. If you see here, every glassware, you can find some markings. There are some color codings also. This is red, this is green, something like that. And see, it is A, EMI, M50, something like that. A is there. So some numbers are there, some marks are there, some color codings are there, and gradations are there. What are these? We need to know what are all these things. Okay, sorry. This is the marking. Like if you see some volumes, 50 ml or 100 ml or 200 ml, if you're seeing some volume units, it is the volume of the equipment. This 50 means 50 ml. It's a volume of the equipment. Temperature. If you see any temperature at which the volume applies. See, you need to take out the volume at that particular temperature only. If it is usually 20 degrees, we have to measure it at 20 degrees centigrade only. Otherwise, it will deviate the volume. If you see A or B in the glassware, means A means class A glassware and B class B glassware, like that they will tell, which defines the tolerance of the stated volumes. See, it tolerances, its accuracy. If it is A, it is very accurate than B glassware, like that. And if you see some identification number, if you see identification number identifies a specific item is included on any certificate of calibration of the item. So suppose it's calibrated. So which certificate is reflecting this? So the traceability for the traceability, we need some identification number. So you will find some identification number which reflects in the calibration certificate. If you see BS, ISO, DIN numbers, it indicates the item complies with the stated British standard or international or German. So, ISO means international standard, BS means British standard, and DIN means German standard. So it qualifies, the glassware is qualifies for these standards, British standard or international standard or German standard. If you find BS or ISO and DIN on the glassware, and you can see some seconds, it means the liquid delivery time for a pipette or burette. You see it is a delivery time. You can see some seconds in the glassware. And X or in indicates the item either delivers, or if it is delivers, it shows EX, or contains IN in the stated volume. Okay, if it contains so IN is means it contains, so EX means it delivers. So it is a representation. Next, blowout is very important. See, it indicates that residual liquid in the tip is part of the stated volume and must be blown out. So if it is blowout, you have to blow out the residual solvent at the last tip of the pipettes. Suppose if you find any pipette, the last tip of the residual solvent solution, if it denotes blowout, you have to blow out it. Otherwise, don't do it. Trade name or materials is like you will find some borosilicate or pyrex in the trade names on the glassware. And color codes. Color codes are the different capacities, whether 50 ml, 100 ml. What is its capacity? It denotes color is denotes for the capacity. Okay. Let's move my thing. Right. Selecting a suitable piece of equipment. See, when we are working with, when you want to do any experiment, you have to select a suitable piece of equipment. So let us see. For graduated items of glassware, such as graduated pipettes and measuring cylinders, you should choose an appropriate sized item for the volume that you are measuring. So before starting an experiment, you have to keep ready with the glassware. How you need to select the glassware? Let us see. For example, if the capacity of a graduated pipette should not be more than twice the volume you want to measure. Suppose if you want to measure 5 ml pipette, 5 ml of volume. Okay, if you want to measure a 5 ml volume, or suppose 4 ml volume, or 5 ml or 6 ml volume. So it should not be, you should not take 10 ml pipette or something like that. So 10 ml pipette is not suitable for if you want 5 ml of volume, because it is double the volume. You have to choose either 5 ml, around the 5 ml. Okay, it should not be double the amount what you want. I think it is clear. Next, type of glassware. One second. Many items of volumetric glasswares are commercially available in two classes. One is class A and the other one is class B. Already we discussed. The distinction between the two is based on the tolerance limits. Class A is highly accurate. Class B is not that much accurate as class A. Class A is generally used for quantitative work where a higher degree of accuracy is required. Point clear, it seems. Okay, cleaning glass is very important task. Very important. Clean with a suitable detergent such as T-Pal or Decon. Thoroughly rinse with water. You have to rinse with the glassware with water. Allow to drain at room temperature or rinse with acetone, and then allow to drain or apply a gentle stream of clean dry air. Volumetric glassware should not be washed in dishwasher at higher temperatures or dried by heating in an ovens, as this may affect the accuracy of the graduation marks. Okay, what is the takeaway point? So you have to wash with soap solutions like T-Pal and Decon you can use, and you can rinse with water, and then you can wash with acetone so that water will go off, and then you can apply a dry air. Only you can apply dry clean air on the glasswares, but you should not wash the glassware in the dishwashers at higher temperatures, and you should not keep the glasswares for drying purpose in ovens. So that will damage the gradation marks and its quality also. So don't keep at higher temperatures of oven for drying purpose. Next slide. Okay, I'll come here because it's occupying. Right. Checklist for making measurements of volume. See, this is very important slide. Suppose if you are measuring a volume, how you have to check it? while with your naked eyes, how you will check it. That is most important. And using the volumetric glassware discussed in this section, it is very important to read the meniscus correctly. So we need to read the meniscus correctly. So here shows 3 examples. If you find here A you are seeing, B you are seeing, and C is seeing. So A is seeing from down, from lower end. A is seeing a lower end of the meniscus, and B is seeing from the straight end to the meniscus, and C is seeing at upper end of the meniscus. So which one is correct? So both A and C are incorrect. Viewing the meniscus from below or above will introduce parallax error, so that you cannot measure exact value. So figure B shows the correct position for reading the meniscus accurately. The meniscus should always be viewed at eye level. Okay, these are all some tolerances of class A and class B volumetric glassware. This you can find anywhere. I don't want to go depth in this. Class A, if you see class A glassware tolerance limit is very less compared with class B, because A is accurate compared with the B. So you can find this slide later and you can check. And this is also automatic pipette tolerance limits. Now, end of this slide, I want some questions to you. So question 1, what item of glassware would you use to prepare a solution of known concentration? If you want to prepare a known concentration, which glassware you will choose? The first question. The second question, what does the marking blowout on a pipette indicate? If blowout is in the pipette indicate, what does it means? Third question, what is the main distinction between class A and class B glasswares? Fourth question, how should you read the meniscus of the liquid being measured? Fifth question, list 4 things you should check before using a bulb pipette. These are the 5 questions. Please answer it and check for yourself whether it is correct or not. Otherwise, you can find the answers in this this video. Thank you so much for your patience. We'll go for the next slide.